Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 14, the graph of a linear equation, horizontal and vertical lines. Okay, so they're giving us classwork exercises to do first. So in each of these each of these questions or exercises, you should pause the video, see if you can do it on your own, and then come back. But I'm going to go through and do each one of these. And we're going to start with exercise 1. And since they didn't give us any room to work, I've copied this down to the bottom of the page. And I can extend the page and work on it here. So it says find at least 4 solutions to graph the linear equation 1x plus 2y equals 5. So if I remember from the last lesson, or last couple of lessons, this is how they did it. They set up a t-chart, and x over here, y over here, and the equation in between. And of course I forgot the equals 5. So I need equals 5. I don't want to squeeze that in there. Okay, so now this is y. Okay, so it says find at least 4 solutions. So remember, it's easier to substitute in for the variable that has a coefficient that's not 1. So I'm going to focus on the y, and I'm going to choose values for y. So if I plug in negative 2, then I will get 1x plus 2 times negative 2 equals 5. That will be 1x minus 4 equals 5. And 1x equals, add 4 to both sides, and x equals 9. So I have the point, and I'm going to do another column here just to show you what we're doing. This is going to be my x comma y point that we're going to graph. So I'm going to plot the point 9 comma negative 2. So I have the program website open that is called GeoGebra, and I'm going to input that point 9 comma negative 2 and hit return. So now I go over 9 down 2. So if I zoom out here, so there's my coordinate plane, my grid. So I went over 9, which is halfway between 8 and 10, and down to negative 2. So there's the point A, 9, negative 2. And I'm going to continue doing this, and I'm going to choose another value. How about 0? So let me change colors here, and I'll do 0 next. So I'm going to do the point something comma 0. So it's going to be 1x, or just simply x, plus 2 times 0 equals 5. 2 times 0 is 0, so when y is 0, x equals 5. So I'm going to put a 5 over here, because 5 plus 2 times 0 is 5. I now have the point 5 comma 0. I will plot that in my app here, and it's going to be 5 comma 0 return. Okay, so there's my second point. So if I go into the commands here on this program, it will allow me to draw a line through 2 points. So I'm going to do that now. So if I draw a line from B to A, or A to B, there's that line. Every single point should land on that line now. So I'm now going to go back. It said to at least 4. I've only done 2. Let me change colors, and I'm going to extend this down. And now I'm going to choose a value, I don't know, how about positive 2? Positive 2. Okay, so this is my y value. So I'm going to take x plus 2 times 2 equals 5. X plus 4 equals 5. Subtract 4 from both sides, and x equals 1. So I'm going to plot the point 1 comma 2. So I go into my program, and I plot the point 1 comma 2 and hit return. And as you can see, that point also landed on that line. Okay, so I'm going to choose one more point, and how about I choose a value that's a fraction this time, just to see if it's going to be true for all. So I'm going to pick a value somewhere within here, or how about I choose the value when y equals, I don't know, 3.5. So it's going to be x comma 3.5. So we need to solve for x. So we're going to have x plus 2 times 3.5 equals 5. X plus 7 equals 5. Subtract 7 from both sides, and x equals negative 2. So I get the point negative 2 comma 3.5. So I'm going to plot that on my graph. So it's input, parentheses, negative 2 comma 3.5, and hit enter. And as you can see, there it is right on that line. So it doesn't matter if I chose a fraction, it's still on the same equation, the same linear equation. Okay, so there's number 1. Okay, so here's number 2. Find at least 4 solutions to graph the linear equation 1x plus 0y equals 5. Interesting. So they're leading up to something here with that 0. So this is what this lesson is about. And so the first one was just a review of what we have to do from the prior lesson. Okay, so now I have my table set up. Let me just extend these because I'm taking a lot of space to show my work here. Okay, so I want to choose values for y because it's the variable that's not 1. Whenever we have two coefficients, pick the one that does not have a value of 1 to plug our values into first. If there is one that has a 1, use the other. So I'm going to choose values for y, and I'm going to start with negative 2. So then I'm going to use this equation. 1x is just simply x plus 0 times my y equals 5. Well, x plus 0 times negative 2 is 0, so that'd be x plus 0 equals 5. And obviously that's the additive identity, so x equals 5. So I got 5. So the point that I'm going to plot on my graph is the point 5 comma negative 2. Let's try that again. So it's going to be the point x comma y, and I'm going to plot 5 comma negative 2. So when I go to my graph on the website, I'm going to input a point 5 comma negative 2 and hit enter. So there it is. Over 5 down 2, it's right here. Okay, so we're going to continue. I'll draw a line this time to separate my values. Now I'm going to choose negative 1. X plus 0 times negative 1 equals 5. X plus 0 equals 5. X equals 5. So I have the point 5 comma negative 1. Okay, so hopefully you see a pattern here in what's going on. So I'm going to go to my website and I'm going to put in the point 5 comma negative 1 and hit enter. Okay, so there's A, there's B. Now if I choose a linear equation now to go through those 2 points, here's B going through A. Okay, so now I have this vertical line, okay, straight up and down. And now I'm going to try 2 more, because it says at least 4 solutions. And now I'm going to plug in 0. So I'm going to have x plus 0 times 0 equals 5. X plus 0 equals 5. X equals 5. Okay, interesting. So I have the point 5 comma 0. So I go back to my graph, input the point 5 comma 0, and it landed on this vertical line. Okay, so I'm going to do another one, and this time I'm going to choose a value positive 1, and so I have the point something comma 1. So it's going to be x plus 0 times 1 equals 5. X plus 0 equals 5, therefore x equals 5. So as you can see, it does not matter what I plug in for y. It could be 1,000,000. 0 times 1,000,000 is 0. 0 plus x is simply x. We are getting 5 every single time. So that's what we're trying to identify in this lesson. When y is 0, the x value is always what the equation is equal to. And it's a vertical line. So we have a vertical line when y is 0. So I'm going to plot this last point just to show that it's on there. 5, comma, 1, enter. And so there are my 4 points, and no matter what value I choose for y, I'm going to land on the x equals 5 line. Okay, number 3 says, what is the difference about the equations in exercises 1 and 2? And what effect did the change have on the graph? Okay, so in the first equation, the coefficient of y was 2, and in the second equation, the coefficient of y was 0. The graph changed from being slanted to a vertical line. Okay. Okay, number 4 says, graph the linear equation x equals negative 2. So if I do a table like we've been doing, okay, that just means that x equals negative 2 when y is anything. X equals negative 2, it does not matter what y is. X equals negative 2, okay, I can put a negative in. All these values are going to be negative 2 because there is no y in here, because x equals negative 2 is the same as x plus 0y equals negative 2. So if I multiply any of these numbers times 0, they just go away and I'm left with x equals negative 2. So I can plug any number in for y and I will get x to equal negative 2. So I'm going to graph these points in the website here. So I'm just going to do these points, negative 2, comma, 0. So that's right there. And then I'm going to plot negative 2, comma, 1. Okay, so there it is, B. So it's a vertical line at x equals negative 2. Okay, so I'm going to keep going. A vertical line at negative 2, comma, 3. Okay, so there it is right there. And then I chose just a random value of negative 7. So negative 2, comma, negative 7. Enter. I need to zoom out to see that. And it is down here. So if I drew a straight line now through these points, then all the points lie on that vertical line, x equals negative 2. So an equation of a line that says x equals is going to be a vertical line straight up and down at the point where x is that value. So the line is vertical and it's going to hit the x-axis at that value of negative 2. And that's this point right here. That is our x-intercept is what it's called. Okay, number 5 says to graph the linear equation x equals 3. So again, if I had an x plus 0y, remember there's no y, so it's 0 times y, and it equals 3. So it's y equals 3. X plus 0y equals 3. Then we're going to get x equal to 3 every time. So I don't care if I plug in 0 or a negative 2 or a 2 or a 5. It does not matter because 0 times 0 is 0 plus x is x, so x equals 3. Negative 2 times 0 is 0, 2 times 0 is 0, 5 times 0 is 0, and every time we're going to end up with x equaling 3. So I'm going to plot all these points on the graph to show you. So if I go to a new graph and I plug in the point 3, 0, okay, there it is right there at A. Let me move this up. So we're over at 3, so it should be a vertical line right here. And now I'm going to input the next point, 3, negative 2. And there's B. So now I can go and I can draw a line to make sure they all land on this same line. So if I draw a line from A through B and continue on forever, there it is. And now I'm going to input the point 3, comma, positive 2. And there it is right there. And when I hit enter, it'll give it the value C. And I'm going to do the last one, 3, comma, 5. Okay, and now if I just pan down a little bit, there it is. Let's zoom out. Okay, so there they are. There's the 4 points, and they're all on the line at the point that is 3, comma, 0. So it's a vertical line at x equals 3. So when we have an x equals, it's vertical. All right, keep that in mind. So we're going to be moving on to the next problem. Okay, number 6 says, what does the graph of x equals 0 look like? Well, remember, when we have an x equals, it's a vertical line, and it's vertical, and it crosses the x-axis at the value that it's equal to, which is 0. So where are we on a graph when we're at x equals 0? So I'm going to clear this. Okay, so now I have this graph here. Well, at x equals 0, we are on the y-axis. So I'm going to input that equation instead of doing a table this time. I'm just going to simply type in my variable x equals 0. And as you can see, it's this green line right here. It is the y-axis. So when x equals 0, it looks like the y-axis. What will the graph of x equals 0 look like? A vertical line at x equals 0, comma, which is the y axis. Okay, number 7 says to find at least 4 solutions to graph the linear equation 2x plus 1y equals 2. So again, I'm going to do a t-chart. And I'm going to write 2x plus y equals 2. And I'm going to put y over here. All right, so I have a 1 over here, so I'm going to plug in values for this one because I want to substitute values in for the coefficient that does not equal 1. So I'm going to choose values for x. So I'm going to choose -3, -1, 0, 1, and 3 just for random choices. And I'm going to substitute and solve. So 2 times -3 plus y equals 2. Okay, so -6. Add it over to the other side, add 6 to both sides, y will equal 8. 2 times -1 plus y equals 2. 2 times -1 is -2. Add 2 to both sides, and y is 4. 2 times 0 plus y equals 2. This cancels, and I get y equals 2. So there's a pattern here. -3, I'm increasing 2, increasing 2, increasing. Actually, I picked random values. That increased 2, that only increased 1, so never mind my pattern. And so then we have 2 times 1 plus y equals 2. 2 times 1 is 2. If I subtract 2 over to here, 2 minus 2 is 0. 2 times 3 plus y equals 2. 6 plus y equals 2. Subtract 6 from both sides, and I end up with -4. So there are 5 points. That is at least 4. So now I'm going to plot them. So I'm going to get rid of that last equation. And here's my coordinate plane. And I'm going to plot these points. -3, comma 8. -3, comma 8. And hit enter. I don't see it, so I'm going to zoom out. It's up here somewhere. And there it is. -3, comma 8. I'm now going to put -1, comma 4 in. So -1, comma 4. Okay. How about inside? -1, comma 4. Enter. Okay, so now I'm going to plot the point, or draw the line through those 2 points, and every single value in my table should land on this line. Okay, so now I'm going to go back, and my third input is going to be 0, 2. So 0, comma 2, enter, and I'm on the line. I'm going to input 1 comma 0, and I'm on that line. I'm going to input 3 comma 4, 3 comma negative 4, and I'm on that line. So there's the graph of that line. Okay, so again, we just went back to an equation where there was a coefficient for x and a coefficient for y that was not 0. And the line is not vertical, it is slanted. Okay, number 8 says, find at least 4 solutions to graph the linear equation where, and now we have x is 0, 0 times x, so x is going to go away, and I get y equals a number. Okay, so before we did x coefficient of 0, now we're, or y coefficient of 0, now we're doing x coefficient 0. So I'm going to put an x here. 0x plus 1y equals 2. I'm going to put a y here. Okay. I want to choose values for the variable that does not have a coefficient of 1. I'm going to leave this one alone. So we're going to choose values for x. So I'm going to choose, I don't know, -3, -1, 0, 1, and 3 again. Okay, so I plug in 0 times -3 plus 1y, or just y, equals 2. 0 times 3, -3 is 0. 0 plus y is y, so therefore y equals 2. 0 times -1 plus y equals 2. 0 plus y equals 2, so y equals 2. 0 times 0 plus y equals 2. 0 plus y equals 2, y equals 2. 0 times 1 plus y equals 2. 0 plus y, or just y, equals 2. 0 times 3 is 0, and 0 plus y is y, so therefore y equals 2. Now we're going to graph this on our plane here. So I'm going to input these values, -3, comma 2. And that is right there. And then I'm going to graph -1, comma 2. And there it is. And now I'm going to draw a line through those 2 points because every value that is in my table should be on that, or I made a mistake. Okay, so there it is. There's a horizontal line. So now we see what's going on. If the y is always the same, that's going to be the value of the y value of every point we put on there. So now when I plug in the point 0, comma 2, I get a point on that horizontal line. And I'm going to keep going with the 1, comma 2 and the 3, comma 2. And there you have it. Every single point is on that horizontal line. No matter what I plug in for x, y will always equal 2. So, if I do not have an x, if x is 0, then the line is horizontal. If y's coefficient is 0, then the line is vertical. Okay, question number 9 says, what was different about the equations in exercises 7 and 8? So if I scroll up here, the difference between 7 and 8 is right here. The 2 is the same, the 1 is the same, the 2 and the 0. So my answer is, okay, in the first equation, the coefficient of x was 2. Right there. Coefficient was 2. In the second equation, the coefficient of x was 0. The graph changed from being a slanted line to a horizontal line. Okay. Okay, so now it says on number 10, it says to graph the linear equation y equals -2. What that means is y is always -2. So I'm going to do this differently. I'm just going to put points on there. Okay, so I'm going to plot points this time. So I'm going to pick a value, a point, and I'm going to put it there. So I want y to equal -2. So y equals -2 is right here. So I'm going to put a dot there. That is the point 0, comma, -2. And as you can see, the y value is -2. So where else is y equal to -2? Well, how about here? 1, comma, -2. The y is -2. Or maybe here, or maybe here, or over here, or how about over here? So if I hover over any of these, the point here is -5, -2. The y value is 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 -2. So if I draw a line now through these points, that is the equation, that is the graph of the linear equation y equals -2. Number 11 says to graph the linear equation y equals 3. And again, it's y equals. So if I just choose points, y equals 3 is right here, over 0, up 3. There's y equals 3. And you can hover over it and check, and that is the point 0, 3. I can come over here and put a point here, and that is the point 6, 3. So now if I draw a line from one to the other, like so, then no matter what point I choose on that line, it's going to have a y value of 3. -3, comma, 3, the y is 3. How about over here? 3.28, comma, 3. So even fractions, doesn't matter. X can change all it wants. Y is always 3. There's 8.68, comma, 3. Okay, so you get the idea. There's the graph of the linear equation y equals 3. Horizontal line when y equals a number. Okay, number 12 says, what does the graph of y equals 0 look like? Okay, well, if y equals 0, where are we? If I put a point here, what's the y value? It is 0. If I put a point over here, I'm off a little bit, so let's undo that. If I put a point here, having trouble getting right on the line, there we go, then that's the point 6, comma, 0. So if I draw a line from A to B, that is the line on the x-axis. So what does the graph of y equals 0 look like? It's a horizontal line. Okay, a graph of y equals 0 will look like a horizontal line that goes through the point 0, 0, the origin, and it will be the same as the x-axis. So if we go back to that graph, it definitely does go through the origin. So if I put a dot right there, not a line, a dot, if I put a dot right there, then C is the point 0, 0. That line does go through the origin. Okay. Okay, that is the end of lesson 14. Review the lesson summary and go to your problem set.